In this video, we are going to talk about how to solve by quadratic formula. So the first thing we're going to talk about is this expression that's b squared minus 4ac. And this is known as the discriminant. So what does the discriminant do? The value of the discriminant can tell you how many solutions your quadratic equation has. So let's talk about that. If the discriminant is positive, meaning a positive number, then our quadratic is going to have two real solutions. If our discriminant is 0, that means our quadratic is going to have one real solution. And if the discriminant is negative, that means our quadratic is going to have no or 0 real solutions, but it could have up to 2 imaginary solutions. So let's calculate the discriminant for each of these examples. So we're going to use b squared minus 4ac. A is 1, b is 2, c is 1, because remember we're doing ax squared plus bx plus c. So I'm going to do 2 squared minus 4 times a times c, which is going to give me 0. Now when it's 0, this means I would have one real solution. So the same thing for number 2. A equals 2, b equals 5, c equals 3. So I'm doing b squared minus 4 times a times c. So I'm going to type this whole thing in the calculator, and I'm going to get 49. Since it's a positive number, that means I'm going to have two real solutions. Let's try the same for 3. A is 1, b is 2, c is 6. So b squared minus 4 times a times c. I'm going to get negative 20. So what this means is I have no real solutions. I'm going to end up with 2 imaginary solutions. All right, 4 is a little bit different because it's not equal to 0. So before I can decide what a, b, and c are, my equation needs to be equal to 0. So I'm going to minus my 7 over. Then I can see that a is 1, b is negative 6, and c is negative 7. So I'm going to do b squared minus 4 times a times c. And I'm going to end up with 64. So again, this is a positive number, just like in number 2. So I'll end up with 2 real solutions. All right, so the discriminant is part of our quadratic formula. It's the part that goes underneath our radical. So we are now going to talk about the quadratic formula. And this formula always works. So if we can't factor, if we can't do the square root method, quadratic formula is going to be our go-to. So x is going to equal the opposite of b plus or minus the square root of b squared minus 4ac. All of that is over to a. But again, we have to make sure that our coefficients are in the right order, and it's got to be in standard form and equal to 0. Those are really important things. So let's do an example of our quadratic formula. So again, my equation's not in standard form, it's not equal to 0, so I need to make it equal to 0. So I'm going to minus that 6 over to the other side, so my equation is equal to 0. Then I need to identify what a is, what b is, and what c is. So in this case, my a is 4, my b is negative 5, and my c is negative 6. Now I'm going to plug each of these values into my formula, and I always write my formula out before I start plugging in, so that way I have it written out. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, well b is already negative, so we're going to have negative b, which will end up turning positive. Every number I plug in for b and a and c, I'm going to put in parentheses. So b negative 5 squared minus 4 times a, which is 4, times c, which is negative 6, all over 2 times a. So when I go to simplify this, I'm going to do a couple of things. First, I'm going to look at this negative 5, and I know that's going to become a positive 5. Next, I'm going to type in everything that's underneath the square root. Not the square root symbol, just everything underneath. So I'm going to leave the square root symbol and find out what number this is underneath. So if I do parentheses negative 5 squared minus 4 times negative 6, I'm going to get 121 underneath my root. The last thing I'm going to do is this 2 times 4, so I can get a denominator of 8. Now, from here we need to check if our square root is simplifiable. So first I'm going to check if it's a perfect square. So I'm going to plug 121 into my graphing calculator or a regular calculator. And actually 121 is a perfect square. The square root of 121 equals 11. So this is actually going to change into 5 plus or minus 11 all over 8. So now we're going to end up with two real solutions. So first I'm going to do 5 plus 11 all over 8. Then I'm going to do 5 minus 11 all over 8. So I'm going to have 16 over 8, which will simplify to 2. Then I'm going to have negative 6 over 8, which will simplify to negative 3/4. And so those will be my two real solutions. All right, let's go through a couple more examples. Before we do that, though, let's practice writing our quadratic formula out, because the more times I write it down, the more times I'm going to remember it. So x is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And we use this when our equation is in standard form and equal to 0. So let's use this on number 5. So again, number 5 is not equal to 0. So I'm going to move this the negative 24 over by adding it. Now I can identify what a, b, and c are. So a is 1, b is negative 10, and c is 24. So I'm going to write my formula over here. Opposite b plus or minus the square root of b squared minus 4ac all over 2a. So negative 10 plus or minus the square root of negative 10 squared minus 4 times 1 times 24 all over 2 times 1. So again, first I'm going to simplify this negative 10 in front to be a positive 10 because it's a double negative. Then I'm going to simplify what's underneath this radical. So the square root of negative 10 squared minus 4 times 1 times 24 is going to give me 4. And then I'm going to simplify this 2 times 1, so I'm going to have 2. So again, I want to check if 4 is a perfect square, which it is. So what's going to end up happening, I'm actually going to go this way, is I end up with x is equal to 10 plus or minus, well, the square root of 4 is 2, all over 2. So I'm going to do 10 plus 2 over 2, and then 10 minus 2 over 2. So I'm going to end up with 12 over 2, or an answer of 6, and then 8 over 2, or an answer of 4. And those would be my two solutions. 6 is already in standard form, so I'm going to just identify A, B, and C, and then I'm going to plug them into my formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is going to equal negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 4 all over 2 times 1. So first, this negative parentheses 1 is just going to become negative 1. 1 squared minus 4 times 1 times negative 4 is going to become 17. And this 2 times 1 is going to become 2. Now, 17 is not a perfect square. 17 is also a prime number, so I can't simplify the square root of 17. So when it's not a perfect square and a root I can't simplify, I just leave it, my final answer, like this. All right, let's take a look at number 7. So again, this one is already set up equal to 0. So the first thing I'm going to do is identify A, B, and c. Then I need to write down my formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b is going to be negative 5 plus or minus the square root of negative 5 squared minus 4 times a times c all over 2 times a. So negative 5 becomes positive 5. I'm going to simplify what's underneath my root here, and I'm actually going to get a big number. I'm going to get 177 all over, and then I'm going to do 2 times negative 2 to get my denominator of negative 4. So 177 is not prime. It actually breaks down to 3 times 59, but there are no perfect squares that go into 177, so this will actually end up being our final answer. All right, and 8, it's already set equal to 0, so I can identify a, b, and c right away. Then I can write my formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 3 plus or minus 3 squared minus 4 times 2 times 3 all over 2 times 2. So x is going to equal negative 3 plus or minus the square root of, I'm actually end up getting negative 15. So we talked about yesterday when we're solving square roots is that when we have a negative underneath the square root, what that actually breaks down to is the square root of negative 15 is the square root of 15 times the square root of negative 1. The square root of negative 1 is I. So my final answer is going to be negative 3 plus or minus the square root of 15I all over 4. All right, let's look at number 9. So again, it's already equal to 0. So a is 3, b is negative 6, c is 3. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 all over 2 times a. Okay, so negative 6 becomes positive 6. Then I'm going to do what's underneath my root, and I'm actually going to get 0. So when we get 0 under our root, we actually end up with just one solution. And this is because the square root of 0 is just 0. So I would end up with 6 plus or minus 0 over 6, which just ends up being 6 divided by 6. So my only solution is 1. So when we get 0 under our radical, we end up with just one solution. All right, let's take a look at this last one. So a equals 1, b equals 6, c equals negative 3. So x is going to equal opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So x is going to equal negative 6 plus or minus 6 squared minus 4 times 1 times negative 3 all over 2 times 1. So this negative parentheses 6 will become negative 6. This part underneath the radical will become 48 all over 2. Now 48 is an even number, and it also will have perfect squares that go into 48. So if I think about how I'm going to simplify the square root of 48, I'm going to think about all the perfect squares that are less than 48. And the biggest perfect square, 36, does not go into 48, 25 does not go into 48, but 16 does. So this square root of 48 is the same as the square root of 16 times the square root of 3. Well, the square root of 16 is 4, so the square root of 48 is going to simplify to 4 plus or minus 3. So instead of the square root of 48, I'm going to have negative 6 plus or minus 4 square root 3 all over 2. Now, this can simplify a little bit more because 6 and 4 are both divisible by 2. So I can think of this as negative 6 divided by 2 plus 4 root 3 divided by 2. Because remember, I want to divide everything by 2. And so I'll end up with negative 3 plus 2 root 3 as my final. Plus or minus 2 root 3. Don't forget about that plus minus as my final answer.